Sure. Okay. So, hi everyone. I'm Spiros. I'm a software engineer at CERN, and I'm a core developer in OpenStack Magnum. So I will talk about how we use OpenStack Magnum at CERN and the use cases of containers we have, and some scalability tests we did with our service and Kubernetes. So as I said, I'm a core developer in Magnum. We are the OpenStack Containers team. We offer an API service that offers Kubernetes, Docker Swarm, Mesos, and DCS experimental as a service. So with 2 clicks, you can have a cluster running, and you can talk directly to the API of what it shows, Docker Swarm, Kubernetes, or Mesos. So what Magnum does is it orchestrates compute instances that can be either VMs or bare metals. It creates networks like tenant networks or public networks and load balancers. It also configures storage for container storage or for persistent storage. We can also deploy the certificates you need to have a secured service, like TLS credentials for etcd, TLS for the kube API server, and of course you have the container native API. So if you use Docker, you do Docker run or Docker PS or whatever. And if you use Kubernetes, you use kubectl, and Mesos we use Marathon, and DCS has its own UI and its own API. So Magnum mostly focuses on lifecycle operations. So the current available is create, delete, and scale up and down the cluster, and we have more in progress. So this is the architecture of the service. So on the right side of the screen, we have the Magnum user that creates a cluster, which has a special cluster driver. So if you are an operator, you can customize your driver and do modifications of how Kubernetes or Docker is deployed. And the orchestration service, which is hit in OpenStack, it creates the cluster. And then we pass our scripts with CloudInit inside the nodes, master nodes and worker nodes, and we deploy the service. And then on the left side of the screen, we have the native API of Kubernetes or Docker, so we can use the tools or directly the REST API. So the OpenStack has 2 releases per year. So the next release is in 2 weeks. And these are the plans that we have for Pike, which is the next release that will be in August. So we want to manage upgrades of clusters. So it's either upgrade Kubernetes only, or upgrade Docker underneath, or upgrade Docker. And we plan to do it like rolling upgrades with node replacement. We also want to support heterogeneous clusters. So to create on OpenStack always clusters in different availability zones, or with different hardware, or with different flavor. For example, have a bunch of big nodes and a bunch of small nodes. Also very soon we will release the Docker Swarm mode, which is not available. We will use the legacy Swarm for now. We're also working on provide a solution for container monitoring that on deployment time with Prometheus. So I just saw about the operators. We might do it with an operator, maybe. But it's to monitor Kubernetes itself, not to monitor something else. And we're going to improve the support for cluster drivers, so we can allow different companies with different use cases modify their drivers and customize it to their needs. And to extend a bit our bare metal support, which is only limited to Kubernetes for now. So about our infrastructure, this is a screenshot taken this week. So we run at the moment 60 Magnum clusters, if you can see. But we have a very big infrastructure, so we can create a bunch of them more. So the use cases at CERN. So for you that don't know what CERN is that we have a particle accelerator that accelerates particles in nearly the speed of light, and we smash them together and we take pictures of them and we cite them as events. So the first use case is batch processing, that is a distributed system that tries to do event recreation from from the metrics that the sensor did. We also have end user analysis with Jupyter notebooks, because physicists want to analyze the data. And to allow them to do it easier, we have these notebooks so they can do analysis on their browser. Also, use cases for machine learning with TensorFlow, deep learning. So physicists are more into that. We just provide infrastructure. We also have infrastructure management, like moving data across the various data centers that are used by CERN users. And then web servers, platform as a service, continuous integration like GitLab CI, and many others. So this is a history of Magnum at CERN. We started starting looking into 2015, and in the beginning of 2016, we had the first pilot service, and later last year, we opened it to all users. So we modify, as I said, with cluster drivers a bit the upstream Magnum to support HEP services with such as CVMF SAEOS, which mounts data from the LHC, and we investigate how to do that with system containers with Atomic, so if you want to have a look. So this is how it looks like for a CERN user to use Magnum. We have this public cluster templates, which is Swarm or Swarm high availability, Kubernetes high availability, and this is the workflow. So you do cluster create, you specify the node counts, you wait a bit depending on how many nodes you want, then you do list and you see that it's create complete. You do one command create config that fetches all the TLS credentials you want, and then you talk to Docker or Kubernetes like you do normally in a deployment. So how is this service, how good is this service that we offer? So we did two benchmarks. One is to benchmark the service. So is Magnum able to serve many users? How does it scale? Can create all these clusters? And the second one is, what are these resources good to use? Is the performance good or is it low? So we use the Kubernetes benchmark that the Google Cloud team released that creates some load bots and some HTTP servers that serve a static file, and you scale up and down for that. So we did the test in two data centers, one at CERN and one at CNCF cluster in Las Vegas. So our deployment has 240 hypervisors with 32 cores, 100 hypervisors at CNCF. We use similar configuration for Magnum and HIT. HIT is the orchestration service. At CERN, we used our production service, so we have more controllers for RabbitMQ, which is heavily used when you create clusters. But in CNCF, we use the upstream Ansible scripts, so you can replicate what we did at CNCF using the Ansible scripts. And we have a bit small difference between CERN and CNCF. At CERN, we have a flat network, so all the VMs are in the same network. But at CNCF cluster, we had tenant networks. So this is the result at CERN for both tests. On the left is how to benchmark the service, how fast you can create VMs, so clusters. So for two nodes clusters, which are essentially three VMs, one master and two workers, in 2.5 minutes you can have it, and we created 50 clusters at the same time. And as you can see, the time scale is a bit stable until 100 nodes, which is about 5 minutes. But then we started to see that the scale is linear, and for 1,000 nodes, we did like 25 minutes, which is still pretty good. But as we noticed, there is still room for improvement. And on the right is the Kubernetes benchmark. So in this example, we managed to serve 7 million requests per second with 500 servers, 500 Nginx servers serving a static file, and 9,500 load bots hammering these servers. And we had like pretty good latency, about not pretty good, but reasonable, 15 milliseconds. So about the Kubernetes test we did at CNCF, we managed to have similar numbers, but we didn't scale very much, just to reach 1 million requests with 100 HTTP servers and 1,000 load bots. And the deployment of clusters is very similar. For a small cluster, we needed 3 minutes. At CERN, we need 2.5. But then we must refine our Ansible scripts to do a better deployment of RabbitMQ. So we didn't have exact measurements about how it performed when we created many more clusters. So we were only able to measure that we created successfully 200 clusters. Then our benchmark already broke. So that's it. I hope you like the presentation, and thank you.